So when you've run a query, you probably also want to, okay, let me share my screen. Can you see my screen? Can you see my screen?
Yes.
Yes, we can.
Right, so I've actually been playing with the database now to see what would work and what will not work. I mean, the database that we all have, I've been playing with it. So I'll create a new query page so that we can work from that one. So last week I wanted us to finish this is of last week's work, right? So sorting results. When you have run a query, you want to be able to present your results in a way that is appealing and pleasing to the eyes and to your stakeholders. Results. So you want to do that, and then we did the select statement from statement, which we said are mandatory in every SQL query, select and from. We said the other keywords are used as and when necessary. The last one we experimented with, or we worked with, was the where clause, and we saw various variants. We saw various different variants of the where clause. Today I want us to look at the order by clause. Order by. So the order by clause is what is used in sorting results. Order by. So again, let me use, I think I'll use this database we have here. Select. I'm still within the database. So let me select. Let me select from employees, dim. Dim employee. Or should I set? No, let me select all. Select all. Select all from dim employee. And if I execute this, you see the results we have. I'm looking at I'm looking for something. Let me just restrict the view. Okay, let me just restrict the, okay, let me do this. Instead of that, let me just do that. Select first name. First name. Last name. Last name. Let's just have this view, right? Let's just have this view. First name, last name. From employee. Now you see that the first row starts with a guy, with someone called Guy Gilbert. Then it goes to Kevin. Then it goes to Roberto, Robert, in that order, right? So it's all over the place, actually. It's all over the info. The data is all over the place. So you can actually you can sort this out by using the order by clause. Order by. So what do you want to order by? You can choose to order by first name or last name. So let's say we want to order by the last name. Order by last name. And now let's see what happens when we run the same query. So you see that there is a change now. The names are ordered in alphabetical order on the last name. Abbas, Said, Abercrombie, Kim, in that order. So it goes in that order until we get to the very last person, who is Zwilling Michael. Right. So from this, what can we say? We can conclude from this that when you just do an order by, the sort is in ascending order. Is that true or false? Is that true or false? Is it in ascending or descending order?
Yes, it's true. Ascending order.
Right, it's in ascending order. So to check, we can do this. This stands for ascending, ASC. If we run this query, there wouldn't be any change at all to the results that we have here. It will be the exact same thing. Now we can also sort this out in descending order. Descending order, DSC. And we have the names changed around, starting with the one with the, so now we have Z as the person whose surname starts with the highest of the Z in the Z zone. So that's Zwilling Michael. Is that okay? Now we can have a compound sort. So we can, for example, have a compound sort. Last name, first name. Let me put first name first. Oh, let's see. Let me put this first. Last name. First name. And notes, check, see if you can find it. You can see any difference between this query and one we run previously. I hope we are all doing this anyway. If I'm too fast, let me know so that I can slow down. So this is data that we all have, so we can all execute at the same time. Is there any difference between this and what we did there? There is no difference. Reason being that, no, let me ask, is there any difference at all? Can someone unmute and let's know if if they notice any difference at their end? No difference? Right, okay. There's actually no difference between this and that. Reason being that now when you run the sort, pardon?
So I am not able to do what you're doing because I don't know how to go about it.
Why is it you're not able to? Can you let us know? Do you have the database?
I have it. So is this
Okay, let me stop sharing. Share your screen, let's see.
I don't know what to share.
You have the SQL, have you installed SQL, the SQL Server Management Studio?
Yes.
And do you have your data in it? Do you have the database in it?
We did that yesterday.
Pardon?
We did that yesterday.
Right, so you have your data in the database.
Okay, so are we using the studio now?
Yeah, that's what we've been using all this while. We've been using the studio. Even last week we used the studio, the database management studio, but I use the different data sets. That's all. It's a data set. It's a different data set that I'm using today, and what I'm just using now, we all have. At some point today, I would change it to my one because I haven't yet been able to figure out which queries to run on some of the things that I want us to go through, which tables to use in the database that we all have. Yeah. But at the moment, we're using the database that we all have, and that is so. If you would share your screen, we can assist. We can look at what you have, and then we can. Okay, so click on databases. Let's see. Click the plus. Okay, so you have AdventureWorks. That's fine. Click on new query. Up in the new query down. Up. One more step. Now to your right, new query up. Okay, so the query pane has now opened for you. So this is where you type in your query. But before you do that, go back to your left. Above Object Explorer, leave File, leave Edit. Come down a bit, come down a bit. Now, go. You see where it says Master? You see a drop-down arrow there. Click on the drop-down arrow and select AdventureWorks. Yeah, that's your database. That is a database that we are working on at the moment. So if you have 100 databases in your management studio, relational management studio, you need to select the database that you want to work on at any point in time. So if you don't choose the correct database, you would get errors in your queries. Your queries may be right, but because you are using the wrong database, they would seem wrong. Do you get what I'm saying?
Yep. Okay.
So what do you want to do, Mariam?
Yeah, I'm just trying to replicate what you're doing.
Right. So okay. Let me leave you to finish. What do you want to write?
I don't know what I'm doing, but I'm just trying to.
Okay, so when the select has to come with something, you don't just write select. What do you want to select? You need to tell the system what you want to select.
Well, how am I going to see the data first to know
All
what
right.
it is?
So you tell me, what is it that you want to select?
I don't know what's in the data.
Okay, so at the moment, we are working on employees. So no, don't go too fast. No, not too fast. The plus sign in front of tables. In front of tables. The plus sign to the left of tables. Come down, down, down a bit, down a bit. Yep, that one. Let it open. So hold it, hold it. These are your table. These are the tables within the database. These are all the tables, all those ones that start with DBO, database object. These are the tables within your AdventureWorks database. You understand that? So when you say when you select, okay, now go up a bit. I want you to just, we are working with employees, so come down a bit. Look for employee there, yeah, that's it. Click the plus sign there. Click the plus sign in front of columns. So these are the column headers. These are the fields in the employee table. All these here are fields in the employee table. Do you get that?
Thank you. Makes more sense now. Thank you.
Right. Now, go up a bit. Let me show you something at this stage. Let me just show us all something. So you see that the employee key, oh, come down, employee key. It has been set as the primary key, PK. Do you see that? Employee key, PK primary key. It's an integer and not null. What this means is that it cannot be left empty. Something has to be put in that field. So if you have every record in that field must contain an integer. That is what it means. Right? Now, if you go down next, parent employee key. Parent employee key, you would see that in the brackets we have FK. Who can tell me what FK means here? FK means foreign key. Foreign key. And what that simply means is that the parent employee key is from a different table. So parent employee is from a different table. So if you look down, if you close the click on the negative sign, yeah, click on that. And then under DBO, dim employee, there's another negative sign, up. Yep, click on that as well. Okay, so there would be an employee parent table somewhere. Employee parent table. If it is not here, it would be in another, it will definitely be there. Otherwise, it would not be mentioned here. So it could be in it would be in another table somewhere. But that is a foreign key, which means that it is imported from a different table into the employee table. Is that okay? So if you can't see it, don't worry about that. I just use that as I just mentioned that to show us what that means. We don't seriously need it at this point. Okay, so a foreign key in one table is actually a primary key in another table. In its original table, it will be a primary key. So if you go into some tables, the primary key in the employee table would be a foreign key in another table. not in another table, in its original table. It will be a primary key in its original table. Okay, so just want to show us some more things. Right,
Thank you.
no problem. So where were we? Let me share my screen again.
Yeah, just a question. What
Yes,
is the
please.
meaning of the DIM in front of those tables?
Pardon?
What is the full meaning of the DIM?
Dimensional.
Dimensional. Okay, thank you.
So, like I said, this query here and that one, though I have done a compound sort, but it's the same. Anybody knows why it's the same?
I think because it's in ascending mode.
Yeah, it's already ascending. It says ascending here, it says ascending there. But why is it the same? There is another sort criteria here. But why is it the same?
Maybe because the last name comes first in the order by.
Oh, beautiful. That's all I'm looking for. That's all I'm looking for. It will first sort on the sort criteria that has been first mentioned before it goes on to the next. Right? So if we switch the field names, you would see that something else happens. First name, last name. So as I think you already are aware now, it's going to give us a different view. So now the sorting has been done on the first name before going to the last name. So the first name takes precedence over the last name in this particular query. Is that okay?
Sorry, Godwin, I've got a question. Mine doesn't have the numbers.
Which numbers?
This numbers in your select and all of that.
You mean the numbers here?
No, at the top.
What have you done? It's there, you really cannot see it.
No.
I think I know what has happened, but I've forgotten. Yeah, I kind of remember that when I started, I faced the same problem. Sometimes I'll be working and my numbers will vanish. But is that I've forgotten how it's, oh gosh, how do you resolve that?
Well, mine does not have number too, though, but
It should have numbers. The numbers are there. I would look into that and get back to you when we do. I've forgotten how it is. In fact, it's been a long time I did it, so I've actually forgotten how I got out. I went around it. It should be it's there.
Okay.
How do you get the numbers? How do you get the numbers there? Which of these gives us the numbers? I've forgotten actually. We will sort that out. We will sort that out. Yeah, it's not a big deal at all. So that brings us to an end of the basic things that we wanted to do with so let's come to today's lesson. Now today I was actually torn between us doing joints and us doing string types, handling strings. But I think we'll just do joints today, and then next week we will look at string handling. String handling is very, very important. As important as joints, because when you are in a place of work, you might want to join 2 or more tables. You might want to join one table, see what is in one table, and join it to another table to give you a bigger view of things happening in the organization. So I've been able to, I could use my own database. Let me switch to mine, and then we would come back to your one, to our one. Before we even do that, let me just let me remain in this database. Who knows how many joins we have? Let's look at joins. How many joins do we have? Any idea how many we have?
That should be like 4.
Or let me rephrase. Who has come across the term joins within the context of SQL?
I have.
You have. Who spoke? I can't see who because I'm sharing. I can't. Pardon?
It's Amina.
Aminat. Okay, Aminat. So can you tell us a bit about what you know about joins?
Joins the way of getting information from different tables and merging them together, or even from the same table and merging it
Oh
together.
wow, from the same table. That's
Yeah.
interesting.
Like the self-join.
Oh, whoa.
So
You've taken me to another level now. Right, that's cool. That's good. That's good. That's good. And do you know how many joins there are altogether?
I can mention them. I may not be able to count.
Okay,
So we have
mention them. We'll count. Mention
self-join,
them. We'll count for you.
self-join, inner join, cross-join, right join, left inner join, right outer join, I think union join. I'm not sure about that.
No, that's
but
it.
I know we have
That's a union is a union. It's different from.
union. So we have cross join. So that's all I know.
Okay, all right. That's very good. Actually, I'm impressed. Did you watch any of the old videos, or it's just or
Yeah, I
you've
did.
actually worked with this before?
I've been playing around with it.
Okay. Okay. Right. So there are actually 6 types of joins. 6 types of joins, but most people will tell you 4, and they are not wrong. And I would explain. So there are six types of joins. 4 are main. 4 of them are the main types of joins that everybody knows. So these 4 are what is called inner join, inner join. The second one is left join. The third one is the right join. Amina, what do you know about the right join?
Okay, so for the right join, for instance, if I have table A and table B, and I write the command to say select from table A, right join table B on the common key. So it is going to pick everything from table A and only pick what is common to table A from table B. So basically everything in table A will be in the result, but only what is common to table A from table B will be picked from table B.
Okay. I'm impressed, actually. You don't need to be in this class. So
No,
like she said,
I'm still learning. I still have a lot to learn.
cross join, and then we have finally the self join. So these are the 6 main types of joins. Not to worry too much about the last 2. The first 4 are the main types that are commonly used. The last one can be very tricky. It's not used often, but it is used once you get a good hang of how to use SQL. It's used. You can use it. The cross join is usually used for given Cartesian products of things. Now, when I say Cartesian products, who understands? Who gets what I'm trying to say? Have you heard of the Cartesian plane?
Is
How
that
many of
like
us did mathematics up to GCSE? I believe we all did, right? So we would have come across the X and Y planes. When you are plotting your graph, you have X and Y, right? The X and Y plane is referred to as a Cartesian plane. So cross joints are used in returning Cartesian products or Cartesian results. Right, things that can map into X, Y, Z, that kind of thing. That's where cross joints come in. So cross joints are usually used mainly by mathematicians, not so much by but it is used also in the business world, but not so much. But the first 4 are the ones that you need to seriously know. And if you mention the first 4 anywhere in any interview, nobody will mark you down. But if you add the last 2, people will look at you with respect, because people who may even be interviewing you may not know. If they don't have a database background, they may not have heard of cross and self join. Right, so let's look at the inner join and how we use the inner join. Let me change my database, and then I'll come back to this one. So we will run the 2 side by side, and you'll see that it's the same command that we use. It's just the data sets that can change, but the way the commands are written are just the same. Right, so if I select, for example, let me select employees, or let me select all. Select all from employees. Now, another thing that's at this stage you want to also get used to is to give aliases to your tables. Reason being that you don't want to have to start writing whole table names in your queries. It would make your queries look very cumbersome, very unclean. So I can give employees an alias E. So select from employees, employee given an alias E. Then I want to inner join this. Inner join this with addresses. So what I want to do here is to find the addresses of all the employees that I have in the organization. So you would have a table that has a table of employees, right? Now you could also have another table that gives you the addresses of your employees. Now the table that gives you the addresses of your employees, before we do this, let me run this so that you see exactly what I'm trying to achieve. The table that gives you the addresses of your employees may not necessarily have your employee names. Right, so if I run this query now, these are my employees, right? Do you see look closely at the field names and tell me if you see any address here.
Just the address ID.
Just the address ID. So with this address ID, who just spoke?
Juliet.
So Juliet, with this address ID, can you tell me where this employee lives?
No.
No. Beautiful. That's the answer I was expecting. You can't do that. Now let's also run this query and see. Okay, because I didn't finish this, it has thrown an exception. Let me comment it out. Now let's run this query and see what is disturbing this. Okay, let me comment all of this. I believe there is a table called addresses. Let me confirm. And there is a table called addresses. I think there should be a table called addresses. Yeah, addresses. So if we run this, let's see, it should give us the correct thing.
Sorry, Goodwin.
Yes.
What button did you use to comment out your query? I was trying to try that.
All right, okay. On this pane on this, the one, just the one before the,
Yeah,
before this? Can you see that?
yes, I can.
Okay, if you see this, these two, this is for commenting out, this is for uncommenting.
Okay, got it.
Yeah,
Thank you.
no problem. Right, so we have this also. So this is a table of addresses. Now we see addresses here, but do we see the people who live at these addresses?
No,
Can we see anybody living at these addresses?
no.
We don't see
No.
them. We don't see the people living at these addresses. So how do we know who lives where? But when we did run this query, where is that one? Where is the employees that I just run? Did I delete it? Okay, let me do another one. When we did this one, we saw address ID here. So you remember I mentioned foreign key, primary key. So let me just as an example, as a side, address ID here is a foreign key in the employee table. The person ID here is a primary key in the employee table, right? The address ID is a foreign key, meaning, and you will see that this address ID comes from a different table. The address ID is the primary key in the address table. Right. So this is it is this address ID that forms a link between the employee table and the address table. Am I making sense? So when we want to join the employee's address, address ID in the employee table to the address ID in the address table. Did that make sense? We want
Sorry,
to
can you
join,
go over that again, please?
we want to join the employee's address ID in the employees table to the address ID in the address table. Remember, when we run the employee query, select all from employees, we didn't see addresses in the employee table. We only saw an address ID. This address ID in this table gives us all the addresses that we need, right? It gives us the address. But to be able to know who lives where, what you need to do is to find which employee lives at which address, right? To do that, you need to join the employee table to the address table. The common link here between the two tables is the address ID. Is that making sense so far?
Sorry, question, please. So I see that you've changed your select from to employees. Did you rename the table as employees? Because
Oh, no, that's
database-
just for demonstration. Forget about that. Forget about
Okay.
these two.
Oh, you're
I'm
not
just
gonna run
using,
that. Okay.
pardon? I'm just using, that's not what we are using for the quiz. I just use this as demonstration.
Okay, thank you.
Yeah. Okay, let me even run both and see whether we can show, both should show. Okay, yeah, we have both here. So you see this address ID in the address table. It shows here. in the employee table. Can you see where my cursor is? So the only thing linking these two tables, if you look at all the column headers, the only thing linking these two tables is this address ID, address ID. And that is what our query is going to be based on when we do the joins. Is that okay? So forgetting about what we have here now, let me just delete this. So inner join, we're working on the inner join, right? Inner join addresses. Addresses A. Remember, I gave employees an alias. So it's only right for me to also give addresses an alias. On. We want to join this onto another table. We're joining employee onto addresses. We're joining employee onto addresses, okay? And how do we carry out the join? So employees dot address ID, employees dot address ID should be equal to addresses address ID.
Hello, sorry.
Yes, hi.
So where is the address table? It's not listed. Was it renamed or something?
This is the address table. I haven't taken it off. This is the
Are-
address table.
Are we
Look
still
at 1
using
to 8.
the? Oh, right. We're not using the AdventureWorks anymore.
No, I'm using my own. Don't worry.
Oh,
I'll use on this particular one. I'll use the AdventureWorks table also.
all right. I've been looking for it. Okay, that makes sense.
I'll
Thank
use
you.
the AdventureWorks table. Don't worry at all. Okay, I'll use the AdventureWorks database. Right. So do you get where I'm coming from? So addresses, employees addresses, address ID is matched onto the addresses address ID. This is what connects the two tables. So when we run this query, we are going to get a result that gives us this. I want you to look at the number of rows of results that are produced here. You can see the number of rows of results that we have, 108. Right, let's do something. Let's do the before I go further, me just do the next join. And then I'll come back to inner join and make some explanation. So once you've gotten the first one, all you need to do is just change that. And when you run this, it gives you that. What do we have? How many records do we have? Can someone tell us?
136.
136. Beautiful. We have 136 records. The first time we had, was it 108 or 109?
108.
108. Okay, so you see that. So can any, oh, what's happening to this? Come on, get off my screen. The inner join, while is good and is it's the best for performance. You want the join that gives you best performance, you use an inner join. You want a join that gives you efficiency, you use the left join. Now, the inner join, when used, loses some data, because what happens with the inner join is that it will show all the rows from the first table. It will show all the rows from the first table, but only if they also appear in the second table. Right? The inner join will show all rows from the first table if and only if they appear in the second table. Now, the left join will show all the rows in the first table, even if there is no matching record in the second table, which is why the left join produces more results. Right?
So does that mean there will be blank address?
We would actually come to that.
Okay.
We would come to that. So when you say there will be blank address,
For the rows that are not in the second table.
yeah, there will be instances of that actually. But let's look at something else. Should we do this on the... Okay, let me do this one first. Let me do another one. Let me do the right. Right, when we run this query, something interesting happens. At this stage, the main thing is I've written the query. All I'm changing is inner, left, right. That's all I'm doing. I'm not making any change. Everything is already set. How many rows do we have here? 109. Now, another interesting thing that happens here is this.
Sorry, Miriam has her hand up.
Oh yeah, Miriam, yeah, go ahead.
Yeah, thank you. Sorry, what I want to know is, you put you added E there, and then if you look at from employee, you put E there,
Mhm.
and then the address you put A there. So I'm trying to see what is the significance of the
Right.
letters. So I'm trying to.
Okay, I think I mentioned this right from the beginning. Now, I said when you're working with SQL, the best thing to do is to learn to give aliases to your
Yeah.
table. So, for example, you're Miriam, right?
Yeah.
You have a nickname.
Yeah.
Okay, so for example, so this employee here, the nickname of employee is E.
Mm-hmm.
Okay, so instead of writing addresses, instead of writing right join addresses, address on employee.address ID is equal to address.address ID. So this basically what this statement reads is that employees address ID should be equal to addresses address ID. Do you understand that? Because I have given aliases to employee and address, I can call on these aliases instead of using the full names.
So
Is that
instead of
okay?
saying employee, you can just say E, right?
Pardon?
Instead of using employee, you can just
Yeah,
say E.
instead of using employee, I've used E.
Okay. Right.
Now look at something funny happening here. Oh, come on. Can you hear background noises? I have some dogs in the house and then they are making. Give me one moment. Yes, so let's come back to right join. Look at this line 106. What can someone tell me about line 106?
Complex. We don't know what is on the under.
Right. So in line one, simply what line 106 is saying is that there is or there may not be someone on our payroll living at this address. We have this address on our payroll as someone who lives there, and we don't know who that person is. So basically, we have a ghost living, a ghost we are probably paying rent for, living at this address. That is what it means. That is what this means. So, what is the way out of this? The way out of this is to never, ever, ever use a right join. Now, when we run this query, the left join, we will get the same results, but in a different form, which is more which can be more better, which can be explained. When we execute these results, we get that. Can we explain that? Yes, we can. Where is that? 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 Let me see. So let me see the details of this. 106. Who is that's Culshaw Close. Culshaw Close, Radcliffe, Manchester. Culshaw Close, Radcliffe, Manchester. Let's see. Look out, see if you can find that address anywhere and let me know.
The ID was 10106.
It was 10.
10106.
Okay, 10106.
Nearly there. Hmm. It's not there. Because you have 10105 and then it skips to 10107.
It's there, it's somewhere. I've used it before, so I know it's there. 10106. Except that finding it now is an issue. One zero one zero 101. Where are you, Ray? One zero one zero six. This one, right?
No, it was the
No,
address
that's not the
ID.
one.
It was the address ID that was
Oh,
also
you are talking about the address ID. Okay, okay,
yes.
okay. 10106. Sorry, guys. One zero one. I can actually use the where clause to get it out, but I don't want to write another query. Where? 101. Okay, let me run this again. It's on line 106, right? Line 106. Address ID is, okay, 10106. Address ID is 10106, 101. Okay. It looks like it's knocked it off. I expected it to be there. But the explanation for this is this. We don't have any employee here, or all employees here are accounted for living at specific addresses. If there is an empty address, if there's an address that is not occupied, if there is an address that is not occupied, it doesn't mean that simply put, these employees here are simply not at their addresses are not on the organization's database. That can be explained. Do you get what I'm trying to say? Now, whereas in this instance where we do the right join, we cannot explain the fact that we do not have employees, but we have rented properties, or we do not have known employees, but we have a property that we are paying for people who are supposed to be employees. It doesn't make sense. Whereas in the left join, where an employee doesn't have an address on the organization's database, the chances could be that they are not provided accommodation by the organization, they are renting their own property, or they have simply not provided their address. But it doesn't make sense that we have an address paid for by the organization and we cannot account for who lives at that address. Right? So we never ever do a right join. Right join is a no. And this can be a common interview question. Well, how do you handle a right join? How do you handle a right join? It's a common interview question. Who can tell us how we can handle a right join? Anything? Any suggestions as to what to do? Never do a right join. Instead of doing a right join, never, ever. Don't ever be tempted. Change your right join to a left join. How do you do that? How do you do that? Very easy, pretty easy actually. It's pretty easy to do a right join, to change a right join to a left join.
Is it by swapping the tables?
That must be Aminat, right?
Yeah.
Yeah. I knew you would know it. So what you do is swap the inner tables, swap them around. So instead of employees being here, let me cut it out. And then I paste it here. And then I cut out addresses. Then I paste that here. Then I change this to right to left. Okay. Oh, actually, this is where we were looking. This is where the 106, the 10160 would have come, not in the original lefts. Yeah, not in the original left, because the original lefts would yeah, because there wouldn't be matching records, so it wouldn't. Yeah, I remember now. So this is where we would see the 1016 something. I've forgotten what it is. So when we run this, the tables are switched, and that makes sense. That can be explained. That can be explained. I'm not sure whether it will still be at 100. Yes, still at 106. Gold short close. There is an address. There is an address, right? On the company's records, there is an address. The address may not be occupied. We can accept that. It may not be occupied. Probably the last person who was there has left. So of course, it's not occupied at a certain point in time. Right? That can be explained. But we cannot explain the fact that we do not have anybody, but we have on standby a property paid for by the company, or we don't know, we simply don't know, we have no clue. Mind you, null is not the absence of something, it is the presence of what we don't know. So there is this address, all right, but we have no clue as to what the organization does with that address. Organizations don't work that way. Businesses don't work that way in real life. So that is how to handle a right join. So simply you have a right join. How do you go about handling a right join? Switch the leading tables. These are the leading tables. Switch the leading tables and then change the right to left. Any questions on this?
So does that mean that there's no occasion where a right join would be?
Right joins simply don't make sense. Even if even if on occasion it does make sense, it creates too much confusion, too much trouble. It is prone to trouble. That's what it is. So it is not recommended. It is not a recommended form of joining tables. Now let me switch this quickly to our database, and then we can see that we can have the same kind of things here. I already got some tables that we can look at today. So I'll just copy the inner join. So now I'm running from AdventureWorks, and I've picked the employee table to run on the employee sales territory. So you see, like when you need to join tables that can have a common link. Not all tables can be joined. You can't join tables that do not link in any form or shape. So I had to go through quite most of these tables today to be able to get a table, two tables that link up. So let me just bring this into that. So this is an inner join, or should I put it? Should I put it under inner join here? Yeah. So this from the AdventureWorks, you see I have selected the employee table. That is this one. This one. Let me just run this statement. Let me just run this statement. The keys that I picked here are the linking keys between the employee table and the employee sales territory was the employee key. That was the common key. So if I also create, if I create another table here, if I create another query here, dim sales territory. If I run this, I would get employee key, right? This key is also, employee key is also inside of this. It's also inside of this table. So I can link these two tables together. Okay, that is why I chose that. I chose these two tables. So if I run this, have I run it already? No, I haven't. I haven't run it. So if I run this now, what do we get? This gives us just 39 rows of data, 39 records. 39 records of data. If we do, remember I said inner join is good for performance, but not so good for efficiency, in the sense that there is loss of data simply because you have to have matching records in the second table for the first table to select those records. So if we do a left for that, if we do a left for this, and we run this, we would get see, this has given us 317 records. That a huge, a much bigger output of results. So we see a clearer picture of what is really there. So actually the best kind of join that you would want to do is the left join. The left join. Any questions so far? And we can do the full join also. Have we done full join already? We haven't done full join, have we? Inner join, inner join. So let me take this out of here. The next one is the full join. We've done inner right, inner left, right, full. If I copy the full join, like the name implies, gives me everything we have in both tables. You just produce everything that we have. So again, I just change this to full. And I change my source data to that. And when I run this, I get that. That is the full for the database in my particular table. If I do the same thing for this, if I do a full for this, remember to change the source of your data based on your query. And I run this. Okay. So that's a full join. So we've done all the four main types of joins. Now let's go to the cross join. Like I said, the cross join is mainly used in returning Cartesian outputs. I haven't finished going through these tables, so I couldn't get a table or a set of tables that we could cross. I couldn't find one easily that we could cross. Here, there was one I found, but the result was just too over the top. So I don't want to bring that in here. Yep. There's this one that I found, but the result was just too over the top. It gives 10,000 results, 10,000. So the way 10,395 plus this result actually doesn't make much sense, in the sense that you get little information out of this. So it's not a good set of tables to use for a cross in this particular case. So I would go back to my table, my database, and then get a good cross for us to use, okay? In that, so for the purpose of actually teaching, 2 tables have already been created from which that can be viewed. Yep. They are just called cross join 1, cross join 2. You see the tables here? They could have been given other names. So the name there really doesn't matter, but because they have been named as such, we have to use the names as they have been given. And that is actually under the training table. So what we have here is we're going to select. First of all, I'm going to select one by one. Select all. From cross join 1. This is what we have. Forget about this numbering here. This is the result that has been produced. This just says that 1 produces 1, 2. Row 1 is 1, row 2 is 2, row 3 is 3. And if I do this one, we have ABC, right? So remember I said it's just like you have the X and Y axis. You want to plot a graph. You want to plot a graph of your stuff. So what you do is cross join. I'll select cross join 2. We join in, select all from this table, cross join to that table. Remember I said the name cross join it could have been anything. I think this name was just given so as to know that this is the table to use for cross joins. So when we run this, let's see what we get. So you see that it's matched, every one has been matched to A, 2 to A, B, 3 to A, 1 to B, 2B, 3B, 1 to C, 2. So it's matched everything. It has formed a kind of if we were to put this on a sketch on the X and Y axis, we can have 1 and then A, 1 and then B, 1 and C, 2A, 2B, 2C, 3A, 3B, 3C in that form. Which is actually why the other one that we run gave us so many rows. It gives the one that we did earlier on. That was the reason why it produced that many results. Because it would match every record in one row with other ones in many other rows. So you see, for example, 1 here that we had in this table, 1 matched with A and then B and C, 2 matched with A and then B and C, 3 matched with A, B and C. Does that make sense?
No.
Yes or no?
No.
It doesn't? Right. So the cross join is just a join to match data. Just to match data. So how do I explain this? So let's assume that we have right. So here we would have 1A, right? If we are matching this and that.
Yeah.
Okay. And then we would have 1B.
Mhm.
And then we would have 1C. And then we would have 2A, 2B, 2C. And then we would have 3A, 3A, 3B, 3C. That's the kind of situation we have. Is that making sense? So it has listed 1A, 1B, 1C, 2A, 2B, 2C. 3A, 3B, 3C. So each number or each item found in this table matches with a corresponding item in the other table. Is that okay?
Yes.
Any questions? Forget about the cross join. You don't need to know about cross join. I'm just showing you cross join. So, like I said, it's mainly used by mathematicians and yeah. So forget about the cross join anyway. But the other one that you might want to know about is what is called the self join. And the self join can be a bit tricky. And like Aminat explained, is joining a table onto itself. Joining a table onto itself. So when will you want to join a table onto itself? Mainly it is when you are trying to drill down within the table to find related data within the table. So it's just that same table. So it's not like there is any join that is called self join. It's not like you use the word self in the join. So the word self is not a word like cross, like full, like right, like left, like inner. We don't use self in any shape or form when we are doing a join. But the way the operation is carried out is what has given the name to the kind of join that it is. It's simply because a table joins onto itself. That is why it is called a self join. So you can do a self join using either an inner join or a right join or a left join. But as we already know, we have said that we should never ever do a right join. So a right join is straight away ruled out of the equation. Is that okay? And the best way to do a self join is to use the left join. Now for this, again, I haven't yet found any table here that we within our database that we can use to do a self join. I haven't yet found one. I'm still looking through the tables to see if I can get one. That will make sense. That's what I mean. So I would use one from my own table, my own self. Let me see where I can get HR. Okay. Let's first of all do this. So this is a table on its own. It's a table in its own right. A table in its own right. But as you are aware, I mean, we've all at some point in time been within organizations. And then we know that in an organization, let's just take even in Blue Sky Citadel, we have levels of management, right? We have the CEO, we have the COO. We have I'm not sure what titles they have, but I think you have an idea of what I'm trying to say. So, for example, if you have the CEO of an organization, they would have subordinates, director of finance, director of HR, director of customer services, director of whatever department or whatever function, right? So there is a hierarchy sort of within every organization. Now, if you have a table just like this, you really don't know who reports to who. You don't know who reports to who. So you want to find out exactly what reporting lines there are within the organization. You want to find out who reports to who and what reporting lines there are. And that is where the self-join comes in. You are working within that same table to drill down on information that you have within the table to extract valuable information from within the table. Right? So you would see that we have person ID, we have full name, and we have manager's person ID. Right? We have manager's person ID. What can we do with this information? What can we do with this information? You see that we don't really have any field that says manager's name. We don't have a field that says a manager, but this is a table for managers. Person ID, full name, manager person ID. I'm drawing this from the manager hierarchy table. So basically, even by the name, you will know that it's a table for management, a reporting line within the management structure. Right, but who reports to who? You can't just leave things blank. So we are going to create aliases. We are going to use and create aliases to differentiate and distinguish between the various managers. So let's start again. Select. Employee.person ID. Employee.person ID. I'm selecting from the manager hierarchy, right? From this table. As employee name. I said we should create aliases, right? See, we don't have employee name here. Or we have full name, but it doesn't say but we can actually leave it as full name, but let's call it that. Full name is full underscore. Manager dot full name. This is a bit tricky, yeah? Manager's name. I want to find out which manager manages the managers. That is what we are trying to do here. Finding out which manager manages the, where is this from? Is it training table? SQL training, okay. I said we use the left join, okay? Left join this, left join the managers hierarchy. Manager hierarchy, which we have given, which we can give the alias as man. On. Manager person ID. And this should be equal to man dot person ID. Right, so what the statement here is saying is this. We want to select the employee's person ID, employee's full name as employee name, the manager's full name as the manager's name. Now, these people here, each of these persons here, all of them would report eventually to just one person. So there is just one person here that manages all of them, but they are all managers. Now, within this management group, there are people other than that one person who manages all the managers. There are people who manage the other managers, or some of the managers. Is that okay? So that is what we are trying to achieve here using this query. So this is a self-join because we are joining the table onto itself. And you can see that we have, for example, full name as employee name. Again, full name as manager name. So employee's full name, the employee who is under this manager. So this employee under this manager, this employee's full name as employee name, this manager's full name as a manager name. So anyone who is an employee to a manager will come under that manager. Does that make sense? And eventually we join the manager's hierarchy. Within that manager's hierarchy, we join the manager's ID onto the person's ID. The manager's ID to the person's ID. And you would see that the managers, their IDs, you can also see some of the managers' IDs here. Some IDs you see here are also here, right? So that is why it is called a self-join. And when we run this, this is what we get. And this tells us that if we take this person, ID 13, whose name is this is their manager. If we take this person whose ID is that, whose name is that, this is their manager. Same for this, same for that. If we take this person whose name is this is their manager. Right? And that is these are employees to these managers. And you will see that the only person who hasn't got a manager is who? Or whose manager is unknown is this last person here, Stephen Knott. And why do you think that might be the case? That could be because this person here could be the top man in the business. This person here could be the director or the CEO of the business. So actually, we can still drill down this further and extract this information. But maybe that is a bit too much. That's going a bit too far now. Any questions so far? Oh, we are all asleep. Hello.
Hi, get in there.
Are we sleeping?
Almost, but we're not awake.
Oh dear. The next one is heavier, so let me leave it at this stage. Maybe next week we can quickly look at the next one. And if you haven't understood this clearly, we can go over it next week, actually. Any questions so far? Mariam, Juliet, Albert, any questions?
No question for me.
None from me. I just need to go and practice with the database that we have.
Yeah.
The-
I'm
the-
also trying to look if we can, for example, like this query here, if we could run it on this, on the AdventureWorks, but I haven't got.
Yeah, unfortunately, we don't have such thing as manager's name and stuff.
Yeah, we don't have an and even when I checked the employee where we could possibly have, it's just there isn't that clear differentiation between management roles. It just lists all the employees just like that. There isn't a hierarchy. This would have been the best. I'll check product category to see if we can use product category. I'll check. I doubt. So these are regional products. These are regional categories. I doubt. What else? Okay, so if there's no question, let's call it a day for now. Let me check organization.